This is the first BlamLib viddoc or vidoc, depending on what company you work for. It's totally unscripted. This is probably the third take I've taken after messing up halfway through it, so bear with me. To start off, there's the low-level assembly, which is based in C++, but it compiles into a .NET assembly. Now, the reason why I use C++ for this is because I use some native-like code that is for byte swapping a real number or a single into a uint. This is done for when you're converting a real number stored in big Endian into little Endian and vice versa. I used to have this in, well, it is in BlamLib, but it's coming out. I used to have this in BlamLib, but I didn't want to keep the unsafe code in there because it complains. The compiler, I believe it's a compiler, it complains. Something complains, and I didn't want to have that in the build. And plus, I also linked to the XNA math utilities for their vector compressions and decompression utilities. This is for the vertex data interfacing with the Xbox One and Xbox 360 based Blam engine game data. Since the Xbox console, since consoles typically compress their vertex data into smaller units, I needed a standardized way to interface with the different types of compressions used. I used to have a code in here that where is it? Oh yeah. I used to use some of this stuff, but I didn't want to have to maintain it, and I had to support many different encodings. So XNA helped with that a lot. So that's why I went with a C++ based assembly for native code interface, and to keep some unsafe code out of BlamLib itself. Now, sorry, to try to give a frame of reference, BlamLib is a interface to the engine's actual data. That is tag files, cache files, scripting, more or less, etc. Whereas the actual open source game modifications are interfaced to the runtime of the engine. That is the actual game as it's running and simulating a game based on a cache file or whatnot. So open source is a game modification, and BlamLib is a interface to data, a standardized interface to data, because it provides a single interface, the tag interface, to interop with Halo 1, Halo 2, all the way to Halo Reach, and even Stubbs, the zombie. You can use a single interface to work with tag files or cache files. So it provides a pretty nice, if I can say so myself, a library to do all this. The tag interface handles everything from Halo 2 tag versioning to providing an interface for extracting tags from the cache and back into a usable source tag format, which I'll give an example here in a little while. So basically, the bulk of all the implementation related code is in Blam. Every major game has its own folder for its implementations for like the cache file for Halo 1. All of its crap is here, or if it's for its tag definitions here, and the code that drives some of it. Or if you wanted to check out Halo Reach, which I have some bare minimum code for. And then going on, we have Chape, which is used in conjunction with OpenSauce for modifying the official editing kits that comes with the game. The PC games, that is. The games folder, it stores the actual definitions that I dynamically load instead of hard coding it into the actual code itself. To give an example, Halo 2 introduced string IDs into the engine, and so I needed a way to track some of the engine-based string IDs, that is, string IDs which are predefined by the engine, because it needs to know about some UI element names, say the campaign selection, or animation names. That's a better example. The engine predefines these in the actual code itself, and then any tag-based string IDs are then given a value after they're predefined. So like the next string ID, which it would be tag-based, would have an index of 5C9. Plus, Halo 2 also used the length of the string ID values string itself. That changed in Halo 3, but that's for another time. I also store the scripting and vertex buffer information in an XML file that can be loaded and unloaded, so I'm not sitting there eating up tons of RAM. And then some utility code for I/O based operations, managers to handle some of the more complex operations like the string IDs. I don't want to have to load the since the engine predefines a certain set of string IDs, I don't want to have to reload those strings over and over again if I'm having to open multiple cache files or tag files. So I can actually use the same predefined group of string IDs for every string ID manager loaded. So if I had 3 Halo 2 cache files loaded, they would have their own string ID manager, which references a single predefined group, but then also for that cache file, it has a dynamic string listing for all that cache file specific string IDs, like anything related to, say, blood gulch on Halo 2 coagulation. It may have a scenario object name, the rock, that wouldn't appear in, say, waterworks. Yeah, I lost my train of thought on that one, so fuck it. Then we also have the tag index. It's there's first a single index interface for which is implemented by a tag file interface, a tag file index class, which deals with actual tag files. And then the cache system has its own tag index. But like say they both implement the tag index interface. So both of them have a open method. So like say it's standardized interface. Yeah. Did I mention this was unscripted? Render, not what it may seem to suggest that it holds. This deals with the vertex formats that the various game engines use. I have a standard definition system for describing each engine's vertex data. To give an example, load up the definitions for Halo 1. These are the actual vertex formats that the resource data holds, and how it stores, say the position is 3 floating point numbers, or if it's compressed, if I can find it, well, here it compresses the normal, which is typically 3 floating point numbers, into a normalized set of compressed numbers. Yeah. Those XML definitions translate into runtime code that those XML definitions translate into objects which define a standardized interface for normalizing and denormalizing a set of real numbers, or a set of encoded bytes. So yeah, that's all the time I'm going to spend on that crap. Going on, we have scripting, which it's pretty much really incomplete. It only provides some basic functionality for interfacing with the scenario tag data. Tag interface, probably the biggest set of code in this code base. Stuff ranging from loading tag files to loading tag data from a cache file, to upgrading a tag, say in Halo 2, an old tag format to the newest tag layout, to extracting a tag from, say, Halo 2 PC or Xbox to a source tag file, which is used in Halo 2 PC, which we'll look at here in a little while. And then some utilities, which you can look at yourself. So next we have the test assembly, which just verifies some of the code behind BlamLib, making sure that any changes that anyone's done hasn't broken the functionality of it. So to give an example here, I have a cache extraction test, and I have the PC one currently enabled because, yeah, I don't want to mess with the Xbox one right now. So currently I have new Mombasa selected, and that is the BSP tag I want to extract. And I also want to extract with dependents and create a database and overwrite any existing tag files in my target directory, which is defined, not there, it's defined somewhere. Well, yeah, go to that method and you'll find where the it extracts to, but it'll extract it here. So if we just give it a little runsy,